All right, you knew it was coming. We can't be talking about all these gas laws for nothing. So, gas laws and chemical reactions. There's actually a particular we're going to talk about when aluminum interacts with chlorine. And there may be a little experiment that I can do during class to kind of demonstrate that, but I won't mention it on here. So, learning goal, determine the mass or volume of gas that reacts or forms in a chemical reaction. Well, okay, cool. So we know we got pressure, we got temperature, we got volume, we've got moles, we've got all of these things. So how does this actually relate to a reaction? And of course, so let's see how it relates. I need my little pen that I'll mess up. Yep, great. All right, so the volume or amount of gas in a chemical reaction can be calculated from the ideal gas law, mole-to-mole factors from a balanced equation, and molar mass. So we're bringing all this together. So we need to know these things. All right, so reactions. State the given and the needed quantities. Organization, organization, organization. We then write a plan to convert the given quantities to the needed moles. So we got to go through our first conversion. Then we have to write the equalities and the conversion factors for the molar mass and the mole-to-mole factors. Then we've got to arrange our formulas, set up the problems, calculate the moles needed quantity, and then finally we got to convert the moles back of the needed quantity to the mass or volume using the molar mass in the ideal gas law equation. Really, we've got 5 steps, but it's no more than a combination of all the things we've already been doing. So don't let this scare you. It's just one more step up the ladder. Okay, it's not a big deal. All right. So it says what volume in liters of chlorine gas at 1.2 atmospheres and 27 degrees C is needed to completely react with 1.5 grams of aluminum. Here's our balanced equation. 2 aluminums plus 3 Cl2s, and S is solid, G is gas, will equate to 2 aluminum Cl3s, okay? So, let's figure this out. All right. Step 1, state the given and needed quantities. Well, we know that Cl2 at 1.2 atmospheres at 300 Kelvin, okay, 27 plus 273, our needs is liters of chlorine gas. Okay, all right, well, we got to figure that out, and we've got our equation to work from. All right, so we've got to first, figure out grams of aluminum, smaller mass, moles of aluminum, and then the mole-to-mole factors, moles of chlorine gas. How many moles of chlorine versus how many moles of aluminum, mole-to-mole factor. All right, so 1 mole of aluminum is 26.98 grams. How do we know this, guys? It's the ultimate cheat sheet. That's right, the periodic table. Okay, so 2 moles of aluminum. So it says 2 moles of aluminum are equal to 3 moles of chlorine. Well, how do we know this? Look at the equation. 2 moles aluminum, 3 moles chlorine. All right, cool. So if we say that, we know that 2 moles aluminum, 3 moles chlorine, or 3 moles chlorine, 2 moles aluminum. Doesn't really matter which way we have it. We just know that this ratio is what we need to look at in this equation. All right. So step 4, how do we figure it out? Okay. So we need to calculate the moles of quantity needed. All right, well, we have 1.5 grams. Okay, we know that there's 26.98 grams in a mole of aluminum. So we're going to divide 1.5 by the 26.98. All right, and then we're going to take that and multiply that by 3 and then divide it by 2 because we want the moles of aluminum to cancel out, leaving us with the moles of chlorine. So we need 0.0834 moles of chlorine to complete this reaction. All right, moving along. Don't let it mix up, and make sure as you're going through these steps that you do it one at a time. Don't jump back and forth. if you keep everything organized now, I tell my math students this, everything has to be organized. It needs to be clean, because when you start jumping around on a piece of paper, all of a sudden, oh, where was that? And you'll lose a number, you'll lose a negative, you'll lose something. We don't want to lose anything. All right, so now that we have what we need from chlorine, okay, we've got that mole value, we can now take this into our V equals moles times our constant, which is that 0.0821, because we're dealing with atmosphere. And how do we know we're dealing with atmosphere? Well, it's right here, okay? And then times the temperature, we knew that was 300. And then over the pressure, 1.2 atmosphere, okay? Because, hey, it said at 1.2 atmosphere. All right, dude, plug and chug. 0.0834 moles, that's what we need from chlorine. Times 0.0821 liters, okay, our constant, times 300 divided by 1.2. That tells us we need 1.71 liters of chlorine gas. Not bad. Just like that. So we just have to remember to cancel, balance, and work through the steps. We got to continue to work through the steps.